I'm Rosalind, a software engineer at Firebase.
And I'm Shruti, a software engineer at Firebase.
And today, we'll be talking about how you can build a more secure application right from the start using Firebase. Let's say that you, a cat lover, have a brand new idea for a game called Fertile, where you score points by clicking on as many cats as you can in a minute. Players can then enter their name to have their score submitted to a high score leaderboard.
That sounds like a great game.
But a few weeks after you launch your game, feedback starts rolling in, and not all of it is good. One of your users complains that someone is submitting low scores under their name. Another user asks why their high scores have been deleted. And to make matters worse, you realize that someone has been cheating by writing impossible high scores directly to your backend.
What a disaster. However, this could have been easily prevented by proactively considering security concerns. Thinking about security can be intimidating, and it might be tempting to put it off until later, after the fun parts of coding your application features are done. However, it's important to be thinking about security from the very beginning, and Firebase makes it easy to do so. With Firebase Authentication, Firebase Security Rules, and Firebase App Check, you can help protect your services, your users, and their data from malicious actors.
So let's consider where Fertile went wrong. One of the first problems the game ran into was that users could submit their scores under any identity, resulting in confusion. This is where Firebase Authentication can come in. As the name suggests, Firebase Authentication allows your users to sign in, or authenticate, within your application so they have an identity that can be associated with their activity in your app. When users authenticate with your Firebase project, they receive a unique user ID. With that user ID, you can associate your users with their data by storing the user ID as a field in database documents or in the database path itself. Now, instead of letting Fertile players submit their scores under any identity they choose, their scores can instead be mapped to their authenticated user identity. Setting up Firebase Authentication is super simple in the Firebase console. First, you enable Firebase Authentication, and then you can enable whatever authentication providers you want to support in your application. For example, Google Sign-In, Facebook Login, Sign-In with Apple, or phone authentication. If you choose to enable email password sign-in, we recommend that you also enable the email link setting so that you can verify that the email address belongs to your user. For integrating client-side authentication logic to your applications, Firebase provides Firebase UI Auth, a drop-in authentication library available on Android, iOS, and web that implements complete user flows for all of Firebase Authentication's supported sign-in methods. If you want more control over the sign-in experience, Firebase also provides Firebase Authentication SDKs for Android, iOS, web, C++, and Unity platforms, allowing you to implement your own authentication flows to suit your needs. With Firebase Authentication integrated into Fertile, players can now be sure that their high scores are attributed to them.
Name collisions on the high score leaderboard weren't the only problem that Fertile ran into, though. As you may recall, another Fertile user provided feedback that their scores kept disappearing from the leaderboard, deleted by malicious users. This is definitely not ideal, but can be easily prevented by using Firebase security rules. Security rules are rules that you write that define custom conditions to authorize users access to specific paths in your Firebase databases. Security rules are enabled by default for all the Firebase database products, although with slight variations in the syntax. Rules for Cloud Firestore and Cloud Storage for Firebase use a language based on the Common Expression language, while real-time database rules use a syntax that looks like JavaScript in a JSON structure. The syntax of both will look and feel familiar to anyone who has worked with JavaScript. Combined with Firebase Authentication, you can use security rules to build user and attribute-based access systems to help keep your users' data safe. However, your security rules are only as secure as you write them. So let's take a look at how to set up some secure rules for Ferdle. Security rules should be in mind early on when you're thinking about the shape of your data. Security rules apply to entire documents, not individual fields. So make sure to keep that in mind when structuring your data. First, let's consider the data that Ferdle may store. A simple Ferdle database might just store a collection of games documents where each game has a player ID field and a score field. While players can view all the game entries on the high score leaderboard, they should only be able to create a game entry for their own player ID and delete game entries that they created. Now let's build out security rules for our data. Every rules file starts with this boilerplate that specifies the version and the service. Within that, we can write statements to match specific document paths. The curly braces around game ID mean that this is a variable we can use in our rules if we need to. Within each match statement, we can specify permissions and conditions. For example, anyone playing should be able to read the data, so we just check that the user is signed in. And anyone is allowed to create a game as long as they are the player listed on the game. Now let's round this out with the condition to delete. Only the player listed on the game can delete a game entry. You can also use rules to validate user data. For example, ensuring that the data contains required attributes or that the data size does not exceed limits. Here, we verify that in order to create a new game document in Ferdle, the player ID field and score fields must be populated. Another useful construct in security rules are functions, which allow you to wrap sets of conditions and reuse them in multiple places. Here, we define the isAdmin function, which is used in both the delete and the update rule. One thing to be careful of though, rules are applied as OR conditions and not AND conditions. So it's important to avoid broader rules that grant access using global match statements or wildcards. These can grant access to your data even when there are more granular rules for a particular document that wouldn't grant the access. To make it easier to start off when you're first developing your app, security rules can be enabled in test mode with open read-write access for 30 days. You can continue to use Cloud Firestore, Cloud Storage, and real-time database free of charge until you reach the no-cost usage limit after 30 days by updating your security rules. Be sure to update your rules to enforce proper conditions before pushing your app to production. As you can see, Firebase authentication is only part of the security story. While Firebase authentication allows you to know who your users are, Firebase security rules are authorization, a powerful mechanism to write granular access conditions and help you ensure that your users only have access to the appropriate data.
Of course, we can't forget the last issue that Ferdle ran into. A malicious user, wanting to cheat their high score, bypassed the game and submitted scores directly to the Ferdle database. Luckily, Firebase AppCheck can help with that. Firebase AppCheck protects access to your services by attesting that traffic to your backends is coming from your application. It does so by utilizing platform-specific attestation providers like Play Integrity on Android, AppAttest on iOS, and reCAPTCHA on web, as well as custom attestation provider support, so that you can better protect your backends no matter what platform you use to build your app. AppCheck is also easy to set up in the Firebase console. You'll just need to register your application to use AppCheck by providing some information in order to correctly configure the attestation providers for each platform. For example, to configure the reCAPTCHA v3 provider for a web application, you'll need to enter your reCAPTCHA secret key. Next, you'll want to configure AppCheck in your application code. Firebase provides Firebase AppCheck SDKs for Android, iOS, and web platforms, and it's super simple to add AppCheck integration into your application with only a few lines of code. If you're adding AppCheck to your application right at the beginning of your application development, which we recommend, Then you can turn on app check enforcement right away, since you won't have any old application versions without app check integration in use. However, if you're adding app check to an already launched app, then you can instead monitor app check request metrics to make a decision of when to enforce app check based on how many verified, outdated client, unknown origin, and invalid requests you have. Firebase app check is currently integrated with Cloud Firestore, Cloud Storage, Real-Time Database, and Cloud Functions, with more product integrations to come. Beyond Firebase, AppCheck also makes it easy to help protect the API endpoints on your own self-hosted backends or custom resources with the help of the Node.js admin SDK. AppCheck also works great with services like Apigee and Cloud Run to add that extra layer of protection, letting you rest easy. With Firebase AppCheck, Fertile users can be confident that the scores they see on the leaderboard are from fellow players, instead of cheaters using a command line.
And there you have it. See how by using Firebase authentication, Firebase security rules, and Firebase AppCheck, Fertile could have been made more secure and avoided the issues that they ran into during its launch.
A question developers may have is, what exactly is the difference between Firebase authentication, Firebase security rules, and Firebase AppCheck? We hope that following Fertile's security journey has helped clarify things for you. But just in case, here's a quick summary of how each of these products helps protect different aspects of your application. Firebase authentication and Firebase security rules deal with user authentication and authorizing user access to data. They help protect your users from malicious actors. Firebase AppCheck, on the other hand, focuses on application identity rather than user identity to protect you, the developer, from unwanted usage outside of your app. Together, Firebase authentication, Firebase security rules, and Firebase AppCheck work together to help protect and secure your Firebase application.
Thank you for joining us to learn about how to build secure Firebase applications right from the start. Happy developing!